Page 770, numbers 1 and 5. We are to, the directions in the book say to use area under a curve to solve each one. We'll do that for number 1, but for number 5, we're going to use the delta definition to solve it. So you can see two different ways to solve two similar problems. Okay, so for number 1, a train travels at 65 miles an hour for 3 hours. How far does it travel? So what you want to do is you want to set up a graph for this, and it just has to be, you know, a nice sketch. So I'm going to count by tens here. 10, 20, 30, 40, 50, 60, and 70. And it's traveling for 3 hours. So 1 hour, 2 hours, 3 hours. So if we were to draw what this would look like, it would be, it's at a constant speed. So it's going to be from 65 miles an hour till 3 hours. So it's going to make this rectangle. And the rectangle's dimensions are 3 by 65. So to find the distance traveled, we're going to take the base, which is 3, times the height, which is 65. So we get that the distance traveled is 195 miles. Okay, so that connects us to our original definition of distance, which is rate times time. Now to use the newer definition with our delta symbols. So the change in distance equals the change in distance per change in time times the change in time goes with this. An airplane travels at an average velocity of 640 kilometers per hour for 3 hours, 24 minutes. How far does the airplane travel? So using this definition, we're going to say that our change in distance is going to be the change in distance per change in time times the change in time. So filling all those values in, we know that our delta S over T is 640 kilometers per hour. And our change in time would be 3 hours, 24 minutes. So before I do that, I have to take 24 minutes divided by 60 minutes in an hour. And I get 2/5 when I simplify that. And that is 0.4. So my time is going to be 3.4 hours. And when I solve that, I get that my change in distance is going to be 2,176 kilometers.